Okay, a screencast that just sums up what we're going to cover in week 11 in case you can't make it or you need to refer back. Last week we had an introduction to creating MVC applications with the Grails framework, and this week we're going to look specifically at how we start to realise domain models or UML class diagrams that express the data model for our application. Specifically, we want to take a UML class diagram and turn it into a database model that we can use to store our data. We're going to look very specifically at some of the things that are legitimate in terms of a UML class diagram that we might want to change when we realise this as an MVC model. Just some interpretive differences that, in terms of transferring from a logical to a physical model, might make sense to do things differently. We're going to carry on becoming more familiar with Git. We're going to use that through each step, and once we've done all this, we're going to look at the database to see what sort of a data structure has been created by our domain model. So we're going to automatically transition from our implemented classes to a database model without writing any SQL. So we need to understand how that transition takes place. Before we get started with that, there are two things, three actually. If you could start up your virtual machines that you've got stored on your ACES VM store drive, get those going early on to save time later on. I'm going to, at the end, there's a URL which references this grails.org page which explains object relational mapping, which is really what we're doing here. We're mapping an object model into a database model. This is the detail of Grails object mapping, so this is a really good reference if you want to understand in detail how this works, in quite technical detail. This is a great resource to read if you wish to. Once your VM started up, you'll have your student login, so remember on the VM that you've all been given, log in as student, the password is password, and you should still have an e-register folder at the root directory. If you're one of the people who had space problems on ACES VM store, we'll cover that separately. For now, I'm going to assume that you've got your e-register application as it was last time. So in your root directory, if you cd into e-register, you've got the root of your Grails application. Just to very quickly go over a way that you might like to have gedit set up. From the root of my project, so I'm in the e-register folder now, I'm going to type gedit /application.properties, which just gives us a file. We could actually do this without a file. So that starts up gedit in this window over here. I'm just going to leave that running now. Quick reorganisation on the desktop. So what I've suggested to you is that in the gedit window, if you view side panel, and then if you go down to the bottom of side panel and click this folder view instead, what you're going to get is a view of your application that represents the directory structure that you can navigate around. So you can go into the Grails app and the web app folder, and here's your conf directory, some files. So then we can edit files, and it's just a little bit of an easier way to navigate your project structure. We can close that down for now. So that's going to be quite a useful thing for us. I just look in here. I'm going to unclick show hidden. Because there's one other thing that I need to very quickly go through. It was pointed out to me late last week that there's actually an issue when we check our projects into Grails, because I've done the right-click filter show hidden, I can see the .gitignore file that Git has created for me. We're using Git 1.1.1, and as you can see from the comment at the top, this is actually a gitignore file for Grails 1.2 and 1.3. And I think you'll find that the top line in your files is something like web-app/web-inf. That really isn't correct. That will actually cause problems in Grails 2.1 onwards because there are files stored in there that we really do need. So, if you could very quickly edit this gitignore file and delete that line, and then save it, and then in a command line, you're going to need to do a git add webapp webinf, I think mine's already added, but it doesn't matter. And then if you do a commit, so you've edited the .gitignore file and you've edited the web app webin file, and git commit -a-n fixed broken git ignore file and added web /web inf folder. Okay, and it's come back and said that, and I'm going to do git push to make sure just that I've got my web app webinf. If you could do that, you'll save yourselves a lot of hassle later on. If you're one of the people who couldn't store their VM on Wednesday last week, there's a different way of solving this. I'll go through that specifically on Wednesday. Okay, so that's the setup done. We're ready to go. We're back to where we were at the end of last week. We're going to take this as our logical model, which I'll talk through in the class a little bit more, but you can see basically we've got the idea of a course, which might be whatever course you're on, and a course is composed of many classes, and the class in this particular case is going to be web architectures, and a class has an instructor, and a class has many registration sheets, so that will basically be one for each occurrence of a class. So there'll be the Monday night class, the first, week 1, week 2, week 3. So what we're going to say is there's a registration sheet for each session, if you like. Session might have been a better name for it, in fact. And obviously each sheet contains entries for a number of students, so we've got a series of very trivial, what equate to relational one-to-many relationships here. One there, one there, one there. The more interesting one, obviously, is that as a student you'll attend many classes and you'll sign up to many different registration sheets, and a registration sheet has many students on it, so we have a many-to-many relationship here. As I said before, obviously there's composition going on here, because it doesn't make sense to have a class without a course that it's related to, and it doesn't make sense to have a registration sheet without a class. Whereas the student can always exist regardless of the registration sheet, so we have a very simple association here. So that's going to be our logical model. There are things in this which already we're going to start to ask questions about. Clearly the idea of an instructor class is a little bit odd, and you might have already spotted there's probably some kind of superclass going on here, which is person, or university person. There's also the idea that obviously Matthew's probably in the room, so there's more than one instructor on this course actually, and there's a role which gets separated between the two, so there are moderators and observers, and lots of different ways that staff or people can interact with this class. So we might want to put some properties on this association that explain the role, and it might end up being a many-to-many as well. For simplicity's sake, we'll leave this as is, at least for now. The student registration sheet one is slightly more interesting in that it's not just a many-to-many. There's a notation which I'll draw in class that allows you to draw a line off here and then have another class which stores properties about the association. So we might actually want to know the exact time that the student signed the register. We might, if we're allowing students to register from the PC that's in front of them, we might want to store the IP address. But that could be useful because the desktop machines in the university are all fixed IP'd, so we can know which room a particular person was in when they registered. Things like that would be quite useful. This model currently doesn't support that very easily. So, as I've said, we've got issues with a superclass around the instructor, staff, student classes, and we've got this many-to-many relationship between the student and the register, which are all very legitimate UML. But actually, for our purposes, we're going to make a few changes, and what we're going to say specifically in this case is we're going to split out a register entry class here. So this is very, very much like what you would do with a relational model, where you have a join table essentially, or a link table. So a student now has many register entries, and the registration sheet has many register entries, and then we can store any additional properties about this intersection in this class. It's useful. I've also added an enrolment just so that we can know which students are enrolled in which classes. I've left the instructor situation as is. That'll give us something to do next week, so that's why that's been left like that. We're going to use MySQL as a database. By default, Grails will allow you to use an in-memory database that is reset every instance, but because it's in memory, of course, it's running for the duration of the web application, and then it's gone. We'd like to have something more persistent so that we can write some SQL against the data that we're producing here, because it will let us tie back the work we're doing in web architectures with work you might have done in relational database subjects. So in order to do that, the first thing we need to do is to set up a MySQL database, and on the VMs that you've copied, the MySQL root password is password. So if I go in here, I'm going to use this terminal for that. I'm going to say MySQL -u root -p password. Oh, sorry, my password is different because I changed it to PA. Not that different. Okay, so I've logged on to MySQL with the root password. So this is something that you all did as part of your Drupal installation exercise, right? You might have used MySQL admin to create a database, which is entirely legitimate. As I said to you when you were doing that assignment, there are lots of different ways of doing this, and what I really wanted to know from you was what you thought the alternatives were and why you chose a particular way of doing it. So here I'm going to show a different way of doing it. Inside MySQL, we're going to run the create database command, which is create database, and then database name. So I've said let's call it eRegister, and it's important that that we set a character set encoding, particularly for web applications. A lot of relational databases have a default character set of some ASCII 7 based or possibly a Windows code page. It's really important for web applications that we use something like UTF-8 or UTF-16, UTF-8 generally, which is a way of encoding characters so that you can encode any character of an arbitrary length, but the smaller characters, the 7-bit characters, still only take up a minimal amount of room. So we're going to create this database using the UTF-8 character set, and the way we do that is by specifying default. Just make sure I get it right. Default char set UTF-8. Now, UTF-8 character sets are interesting. I think now Oracle has UTF-8 by default. MySQL, we need to specify it. We also need to say when you're sorting things using SQL's order by clause, make sure that you use a UTF-8 binary sorting. So we're also going to say default collate UTF-8-bin. It's underscore bin actually. Okay, so we've now created a database called eRegister, which is exactly the same as you'll have done for your Drupal install. Yeah, so you probably did create database Drupal. You might not have used the default character set stuff. There's no reason why you should have, particularly for that assignment. But here it's important. We're building a web application. We need to be able to specify this. We've constructed a database. We now need to grant access to a user. So in the slide, I've said let's grant access to a user called WebArch, and here's our database name. So let's just do that now. Again, you might have done this using MySQL admin in the assignment, but we're just doing the shorthand here. So grant all on eRegister.star to WebArch. Sorry, that needs to be in quotes. At localhost identified by WebArch. Okay, so that's so we've created a database called eRegister with the right character set and collate, and now we've granted access to everything in that database to a user called WebArch, coming from localhost, and their password is WebArch. So we've set up everything we need to be able to connect to that database now. The next bit is a little bit long-winded. Ordinarily, you wouldn't do this. You might just use the in-memory database, but it's really important for our purposes that we're able to see the changes so that you can understand what's going on behind the scenes. That's why we're jumping through these little hoops here. Using your file browser, if you expand the conf directory, you'll see that you have a data source.groovy file. Here what you've got is a set of different environments that really help you work in an agile way. So we have a development environment. This is obviously going to connect to a development database, a testing environment, and a production environment. What we're going to do is we're going to replace the development data source with this one. So, pardon me. I'm going to take that out. Copy that. Hopefully this will work. Yay. Okay, so I've pasted in this section instead. The only real difference, we've changed the driver name. Yeah. We've changed the dialect. So in class I'm going to talk a little bit. One of the advantages of this approach is that we can take a web application and we can implement it on MySQL, and we could take it tomorrow and we could implement it on Oracle, and we don't need to maintain 3 different sets of create database scripts for all the different dialects, because our domain model is dynamically compiled into a set of data definition statements. Then we can just change the dialect and run it against a different database, and all the different variants. So for example, Oracle uses varchar 2 instead of varchar. All those dialect differences, this class is well named, all those differences are dealt with for us, so it makes it really easy to deploy web applications on different platforms, and that's a real strength of this approach. So we've changed the driver which has been used to connect to the database. We've changed the dialect, so this will change what SQL gets generated for us. We've set the password and the username to the ones that we use in our create database. Our grant here. WebArch, good. And then we've set the JDBC connect string, which basically tells this application how to connect to the database. And you can see the only important parts in here are eRegister, that's our database name, and use Unicode is true, and character encoding is UTF-8, is saying when you send text values to this database, make sure they're encoded in UTF-8. So we'll save that, and then we can close it. That's good. And the last thing we need to do is in build config. The MySQL driver, the thing which allows this application to talk to any database, the way that the application connects to a database is through a series of drivers, and you have to make sure you're using the right driver. So there's a driver for Oracle, and there's a driver for Postgres, and there's a driver for Microsoft SQL Server. We just need to, Grails very kindly has added a commented line which has the MySQL connector there, so we just uncomment that line and we save it. So what we've done is we switched this database now from using an in-memory SQL database to an external MySQL database, and we've configured that database so that we can access it. I'm going to save that, and what I'm going to do is back over here, I'm going to say git commit -a -m updated database config, and then I'm going to push that. Because this is a useful unit of work, really, we've switched our database from one to the other, and then we've saved the changes, pushed them up to Git. I'm not going to go to Git and review it. You've got the hang of that now. So that's all our setup done. Sorry, and there's the slide about adding the MySQL driver, which we've just done. One other thing we need to talk about. It's really common in UML deployment diagrams and in package diagrams, which are two of the less common diagrams used from UML, to see things arranged into packages, and packages are a good way of organizing your code so that you can reuse things. So what we've got here is the idea that packages can be arranged hierarchically. Because Grails is based on Java, Java tries to use internet domain names as a way of organizing its package names. So you can see that if we have the eRegister project, which is a part of the web architectures module at shu.act.org, the way that we turn that into a package name is by reversing it, essentially. So we've got the biggest level of granularity here. This is the UK that ends the domain name. AC, this is an academic network. SHU is the institution, and you can see we're going from the general through to the specific. And then I've added a .webarch for web architectures module, if you like. And the current project we're working on in this module is eRegister. So what we're going to do is we're going to put all our source code for this project in a particular package, and that package is uk.ac webarch eregister. This is a really common way of organising your source code into packages, as I said, for reuse, so it's worth getting your head around that as well now. Right, we've done all the grimy setup that we need to be able to do this part now, and I guess it's a common theme with MVC. You'll start to detect it yourself that everything starts with some housekeeping and getting things set up to save yourself. Once you've done the setup, things should be a lot more easy, but there is this little hump at the beginning where you just get everything as you want it. So that's what we've been doing here. We've just been setting everything up so that we can do the domain modeling that we want to do. We're going to create some domain classes now. If I quickly skip back to this this model, what we're going to do is we're going to look at student. Okay. The command we need is Grails create domain class, and then we give it a full package name for the class we want to create. So in this case, we've got it prefixed with the package that we said before, and then there's the class name at the end. So what I'm going to do is, rather than type that, I'm going to copy that. You'll have to copy it or type it, I'm afraid. And here it's important when I run this command that I'm at the root of my Grails application, which is the one where my application.properties file is. Here we are, you can see I'm in the right, so I'll just clear this window. Actually, I'll make this a bit more central so you can see it. There we go. Okay, so I type in my Grails create domain class command, and here's the fully qualified package, UK AC SHU webarch student. Ooh, missed eregister out there, haven't I? Okay, I hit enter. Grails starts up. The first time you do this, if you just added the MySQL dependency, Grails will have to download it. And sorry, on my local machine I've upgraded Grails to 2.1.2 as I'm preparing notes for later on. So that's the reason we've come back with this. In order to work around this, I just say Grails upgrade. You shouldn't have to do this. Everything should just work. So I'll very quickly upgrade this project. You can this Grails upgrade command is just another Grails subcommand, and it lets you switch between versions. That would have been a real headache at one time, but the framework just deals with it for us. So I'll try this again. I'm going to execute my Grails create domain class command. Okay, and this time it's come back successfully. It said, I've created these two files for you. Here's the actual class I wanted created. That's my domain class. And it's also created me some unit tests. So this is quite important, actually. We should talk about this in class. It's very useful, and this is the way that test-driven development is working these days. It's a nice way to work. It's something, if you went to the code retreat day, you'll have seen in action very much. For now, I want to focus on the domain class, though. You remember git status? Git status has come back and told us that we've got some modified files. The files with the tilde at the end are backup files from gedit. We don't want those at all. But the thing that we are interested in is this Grails app domain directory has now appeared, and this test directory. They are things that we need to track. So I'm going to add those now. I'm going to say git add Grails app domain and the test directory, and I'm going to commit them now. And then I'm going to push that change up. Okay, good. Now then, back in my my gedit window, you saw how that domain directory got created there as a part of the class. So we can navigate into here now, and you'll see we've got our package structure reflected in the directory structure. So this shows you how packages help you organize your source code essentially. And at the very leaf, you can see we've got our student.goofy file. Now, it's not particularly exciting at the minute. It's created a class, but there are no properties in there. So you can see, I'll update the slide later on, this should have the eRegister folder name in it. So what we'd like to do now is to actually see what effect this has had on the database. If I'll close MySQL down, I should be able to connect to MySQL using these details. So MySQL -u WebArch -p WebArch, and the database name was eRegister. Yay! So if I say show tables, there are no tables in this database currently. This is a good thing. Creating my student domain model, I'm going to say Grails run-app, and if I've got everything set up correctly in terms of that data source file and my dependencies, so let's just see what happens. So Grails is doing its dependency checks, compiling the project. Warning about a deprecated API, but we don't need to worry about that. Oh, okay, I've made an error in my data source file by using, I think it's because I cut and pasted it. So there's a warning to you about cutting and pasting these things. It hadn't used a double quote properly. Right, so I fixed that, I hope. I'm going to commit it. Found and fixed. Push that fix up to GitHub. Actually, it's possibly not best practice that me showing you that. I should have really tested this after I made those changes and found that before I committed it. Just compressing everything down into a screencast. I've made a silly mistake there, but ideally don't do that. Test things before you push them up to GitHub. So let's try again. We're going to do a Grails run app. So we're compiling. Okay, all seems to have compiled okay. We've got running Grails application. And eventually it'll come back with the URL saying please browse here. Now, the important thing to remember is the only thing we've really made the change to here is the domain model. There's nothing visual in any of this. Just to prove to you the app's running, I'll paste that in there. Okay, so you remember we stripped out all that other nonsense and we've just got this is eRegister as our view page. We don't care about any of that at the moment, but what we do care about is if we now do a show tables, we can see that we've got the student table, and I can say desk student. And all you can see in this table at the moment is an ID and a version number. Now clearly we don't have ID or version properties here, so what's happened is the framework has automatically injected a primary key and a version number that it will use. We'll talk about locking for web applications briefly in class. The version number is a way on top of ordinary relational database locks. Grails, the framework, can manage changes between long-running transactions. I'll try and explain that a little bit more in class. Don't get too hung up on it for now. The important thing is we've gone from having no database schema to essentially a schema which reflects our domain model, which currently is just one class. It's just the student class, but you can see student class, student table, and in future when we make changes to this domain class and run the application, the database will be synced with our model. So if we add particular properties, then columns will get added in the database. If we add relationships and foreign keys, they will similarly get added. So you can see that we're developing a database schema here without writing any SQL DDL, data definition language statements. And those statements are tuned to a particular environment. So these create table statements, very specifically MySQL. So they use MySQL sequence numbers, rather than Oracle seek no table. And the syntax for the foreign keys is the slightly different MySQL variant. So everything that we need for the target database is being done for us. So we've done this, we've done a show table, we've done a desk student, and we've had a look at the differences between the contents of the table and the contents of the class definition. So we want to stop the application now. Sorry, a bit all over the place. So it's running in this window. Remember, Shift-Control-T gives you a new tab, by the way, just in case that's useful for having different windows for running things in. Control-C will cancel the application and brings us back to the command prompt. If I now try and refresh my web application, I should get a not found, because we've stopped the application, so it's no longer responding to requests. Obviously, it's not very useful just to have a table with a primary key and a version numbering. We need to be able to add some real properties. Pardon me. So let's, in our application, say string name, string student number. Just worth noting the capitalization here. What I'll do is I'll say full student name, just to illustrate the point. Yeah, so in my domain model, I've said that the student class has two properties, full student name and student number. I'm going to save that, go back here, do a Grails run app again. Remember, if you're trying this, bring questions and issues back to class and ask them, for goodness sake. I mean, you've seen with the quotes thing here, that's a ridiculous mistake I made. You're going to have to note these things down and bring them back and ask about them if you run into them and you can't solve them. It's a part of the process, learning how to deal with errors. I think, as I said to you very early on, you will make mistakes, we all make mistakes, but the real skill is being able to back them out without doing any long-term damage. Being able to investigate and diagnose what the problem is. So, here we go, we've done a run app and we've got the web app running again. Let's quickly refresh that, prove to ourselves that it's up. Yeah, good. But more interestingly, back to the database now, we'll do a desk of student again, and you can see that we've now got full student name, and you can see how the capitalization, so we had this camel case, full student name, which has been converted into a column name of full underscore student underscore name. Because it's a string, it's been mapped to a varchar, which, as I said, in Oracle that would probably be a varchar 2, and it's been given a default length of 255. So unless we specify otherwise, using the constraints here, which allow us to tune the column types and the lengths and indexes which get created, so we have pretty fine-grained control over the database schema that gets generated. But if we don't want to worry about that, intelligent defaults or convention over configuration, the convention here is that string properties get turned into varchar fields with a default length of 255, and the camel case names get replaced with underscores, so full student name with uppercase S and uppercase N, where we have an uppercase character, it gets turned into a lowercase but prefixed with an underscore. So you can see how changes to the domain model are being automatically reflected in changes to the database. As I said earlier, this is useful for deploying to different database environments where the mappings might be different for different dialects. It's also useful for doing upgrades between versions. So if you think about it, a new version of software is almost certainly going to include some database changes, and it's really nice that what we've got here is a web application that's capable of bringing the schema up to the right version of the schema it needs for the application to run. And that's really useful, because when we used to do deployments, there was a whole complicated issue around making sure that the schema was synchronized with the application you were deploying. Now it's all in one, and the application is capable of making sure that the schema is the way it should be for the version of the software. One side note there, though, is that in larger organisations they quite like to separate out the role of DBA, and most database administrators are not comfortable to have applications executing data definition statements, so they'll sometimes take that permission away from your application. I'm going to just stop the application again there. Grails actually has a command, and I can't remember it off the top of my head, but I'll find out for the class. You can ask Grails, instead of making the changes automatically, to generate you a DDL file, which is the create tables and alter table scripts that would allow you to run that manually against the database. So it's quite useful. You can separate out this auto behavior, if you like, and go back to here's a script I'm going to give to my DBA to upgrade the application so that they understand what changes have been made. I digress. So that's really trivial, isn't it? You know, the student thing with a name and a student number. Let's face it, we've not really saved ourselves any hassle there. We could create the table using the SQL in a few seconds. We're going to look at this this pair here, instructor and class. Now, the first thing I need to say about this is that class, and you'll find this with all MVC frameworks, with all programming languages, class is actually a reserved word in almost every language, as it turns out, but specifically here, class is a reserved word. We don't want to use class as an object, as the name of a class in our system. It all gets a bit meta and self-referential otherwise. If we try and use that, we'll have many errors. So we're going to choose a different name for the implementation of this class. And what I've suggested is reg class, which is fine. You know, we're prefixing the reserved word with reg. It solves the problem. Now, in terms of this model, okay, a class has an instructor, a class has one instructor, and an instructor has many classes that they teach, essentially. Yeah, so that's the thing. We've got two domain classes and an association between them all. And I've said it's aggregation rather than composition because either of these things could exist without the other, essentially. I mean, you might. There is an argument that says maybe the class couldn't exist without the instructor, but that's not true. The class would carry on even if I weren't here. It would be replaced with a different instructor. You know, you might be very lucky and miss a week because no instructor is available, but the class would still be there. So that's why I chose to model that in that way. So the first thing we need to do is to create this instructor and reg class. Now I'm going to just be really lazy and cursor up until I find my create domain class things and instructor was the first one we're going to create. If you look over here as this is running, yeah, there you go. You saw it. You might have seen instructor pop into the list of classes there. I should really turn off backups in gedit. I'll have a look how to do that in a second. And the other class was going to be reg class, I think. I'm relying on the fact that Groovy is going to auto uppercase the first letter of my class name. Doesn't really matter. You could have put reg class with an uppercase on if you wanted. If you watch over here, reg class will pop in. So we can look at those classes, can't we? Good.